Dear students, this is the third lecture of Principles of Statistics during the holidays of coronavirus. This lecture deals with measures of position. As we said before, measures of position is a part of measures of central tendency, but these measures deals with the position, not the location of the measure. Okay, so a measure of position determines the position of a single value in relation to other values in the data set. There are many measures of positions, such as quartiles, quintiles, deciles, and percentiles. Each of these measures divides the ranked data set into equal parts, and the number of each sub-measure equal the number of equal parts minus 1. For example, the number of quartiles is 3, where the number of parts is 4. 4 parts, every part contains 25% of the data set. Okay, so this is called quartiles, ربيعات. The following figure indicates some of these measures and their positions. Look, now we have 1, 2, 3, 4, 5 measures of position. The first is called percentile, deciles, quintiles, quartiles, and the median. So, because we studied the median before as a measure of central tendency for the ordered data, or when the data are quantitative but contains some outliers in one side of the data set. Okay, that's we explained before. Now look, the mean is one measure, only one measure, which divide the data set into two equal parts. Okay, so this position is the middle of the data set. 50% of the observations are larger than the median, denoted by MR, and the other 50% of the data set are less than the median. Okay, so the median divides the data set into two equal parts, and the number of medians is only 1. So the number of parts minus 1. Okay, so the number of measures equal the number of parts minus 1. The second measure is quartile, الربيع. You know that the first quartile divides the data set into two parts. Okay, one part, which is less than the first quartile, represent 25% of the data set, and larger than the first quartile, we have 75%. Okay, so we can say that quartiles divides the data set into 4 equal parts. This one part, second part, third part, and fourth part. And the number of quartiles is 3. So why 3? 4 parts minus 1 equals 3. Okay? For example, the first quartile is the measure that divides the data set into 2 parts. One represents 25% and the other is 75%. So we have 25% less than Q1 or first quartile, and 75% is larger than the first quartile. The second quartile is the median. Okay, so we can say that the median represents the second quartile also. So we have 50% less than Q2 or the second quartile, and also 50% larger than Q2. And the third quartile divides the data set into 2 parts, where 75% is smaller than Q3 and 25% is larger than Q3. Right? Okay. Quintile, خميسات. Quintiles divide the dataset into 5 equal parts. So the number of quintiles is 4. Q1, small q, small q2, small q3, and small q4. Okay? So here there are 20% less than small q1 and 40% less than q2 and 60% less than q3 and 80% less than q4. And we have also 20% larger than Q4, and so on. Okay? So the fourth one is deciles. Decile, عشير, denoted by capital D1. So deciles divides the data set into 10 equal parts, and the number of deciles is 9. 10 minus 1 equals 9. Okay, where there are 10% smaller than D1, 20% smaller than D2. So D2 equal Q1, small q1. العشير الثاني يساوي الخميس الأولاني. D3, the third decile, divides the data into 2 parts, where 30% is smaller than and 70% is greater than. Also, D4 looks like small q2. So العشير الرابع يساوي الخميس الثاني, where there are 40% less than and 60% greater than. Okay? D5, the fifth decile, it looks like Q2 and also looks like the median. Okay, so 50% of the data set is smaller than D5 or the fifth decile, and also 50% of the data set is larger than D5 or the fifth decile, and so on. Okay? The last one is percentile. Percentile divide the data set into 100 equal parts. Okay? And the number of percentiles is 99 or 99. Okay? So every part equal 1% of the data set. Okay? So the first percent divides the data set into two parts. One represent 1% smaller than P1, and the other equal 99% greater than P1, and so on. Here you see that P10 equal D1 and P20 equal D2 and also equal Q1. Okay? And the first quartiles position between P20 and P30. Okay? P30 equal D3, the third decile equal the 30th percentile, and so on. The 40th percentile equal the fourth decile and also equal the second quintile. The 50th percentile is equal the fifth decile and also equal the second quartile and the median. The 60th percentile equal the sixth decile and equal also the third quintile. Okay? The 70th percentile equal the seventh decile and so on. The 80th percentile equal the eighth deciles and equal the fourth quintile. So the fourth quintile equal the eighth deciles and also equal the 80th percentile. And finally, the 90th percentile looks like the ninth decile. Okay? So how can we measure all of these measures of position? Number one, quartiles and interquartile range. الرباعيات والمدى الرباعي. Quartiles are summary measures that divide a ranked data set into 4 equal parts, as we said before, and the number of quartiles is 3. These 3 measures are the first quartile, denoted by Q1, the second quartile, denoted by Q2, which is equal also the median, and the third quartile, denoted by Q3. The data set must be ranked in increasing order from small to large before computing or determining the quartiles. So we can define quartiles as 3 summary measures that divide the ranked data set into 4 equal parts. Okay? The first quartile is the value of the middle term among the elements that are less than the median or the second quartiles. Okay? So here the median looks like the second quartile, and the first quartile is the value in the middle term among the elements that are less than the median or the second quartiles. Okay, which in turn divides the ranked data set into two equal parts. The third quartile is the value of the middle term among the elements that are larger than the median or second quartiles. Okay, the following figure illustrates the position of the three quartiles. Look at this. Here, these are three quartiles, divided the data set into 4 equal parts. Every part equal 25% of the data set. So here Q1, Q2, Q3. First, Q2 looks like the median. So Q2 divides the data set into two equal parts. 50% larger than Q2 and 50% smaller than Q2. So you can say that Q1 is the middle of the data which are smaller than Q2. Again, Q1 is the middle value of the data which are less than or smaller than Q2 or smaller than the median. And also Q3 is the measure of position that lie or locate in the middle of the data set which are larger than the median or Q2, right? Okay, so approximately 1/4 or 25% of the elements in a ranked data set are smaller than Q1, and about 75% are larger than Q1. The second quartile, Q2, or the median, divides the ranked data set into two equal parts, where 50% of the elements are less than the median and 50% are greater than the median. Also, about 75% of the ranked data set are smaller than Q3 and 25% are larger than Q3. By the way, the difference between Q3 and Q1 is called the interquartile range and denoted by IQR, where IQR or interquartile range equal Q3 minus Q1. المدى الربيعي interquartile range. Percentile and percentile rank. المئينات ورتبة المئينات. Percentile are summary measures that divide the ranked data set into 100 equal parts. So the number of percentiles is 99 and denoted by PK, where K is an integer in the range from 1 to 99. The 25th percentile is equal to Q1. That's right. Percentile number 25 equal the first quartile, and the 50th percentile is equal to Q2 or the median, and also that's right, and so on. The following figure describes the positions of percentiles. Here we have 99 percentiles, okay, and we have 100 parts that percentiles are divided the data set. So every part contains 1% of the data set, okay? So, thus, the case percentile is a value that divides ranked data set into two parts such that about k% of the ranked data set are less than the value of pk, and about 100 minus k% of the data set are greater than this value, okay? The approximate value of the kth percentile, denoted by pk, and is computed as follows. Ri equal n multiplied by I divided by k, then plus 1/2. Where R is the percentile rank and I is the rank of percentile, okay? So this is the percentile rank, رتبة المئين, and I رقم المئين. Here is the rank of percentile, رقمه أو رتبته. K is the number of parts of the data set related to the required percentile. هنا K عدد الأجزاء اللي بقسمها البرسنتايل. So K equal 100. Okay. The value of pk is the corresponding value of the percentile rank. قيمة بقى ال P of K البرسنتايل هي القيمة المرتبطة ب rank of percentile أو percentile rank. شوف رقمه كام ونطلع قيمته من الداتا. We can also compute the percentile rank for any value included in the data set. Compute the percentile rank for any value. So now, given the data set or the value, the observation, and compute the rank or percentile rank of any value of these data set. For example, xi, by calculating the percentage of the values that less than xi, the percentage is the number of values less than the percentile divided by the number of percentiles, or 100, or divided by the number of observations in the data set by using the following formula. Okay, Rx1 رتبة القيمة دي equal ni, the number of values less than this value, divided by n, the number of observation, multiplied by 100, where Rx is the percentage rank of the value x, n is the number of values that less than x, and in the ranked data and the n is the number of observations. So in I, the number of values less than x, and the n of the number of elements or observations in the data set. Okay? Deciles and quintiles. العشيرات والخميسات. Deciles are summary measures that divide any ranked data set into 10 equal parts. Each part contains 10% of the data set, and the number of deciles is 9, and they computed by the same way as percentiles. يبقى هنا الديسايلز والكوينتايلز هيتحسبوا بنفس الطريقة اللي احنا بنحسب بيها البرسنتايلز. The first decile is the same as the 10th percentile, as we explained before. The second decile is the same as the 20th percentile, and the fifth decile is the same as the median, and so on. Quintiles also are summary measures that divide any ranked data set into 5 equal parts, and each part includes 20% of the data set. The number of quintiles is 4, and they computed by the same way as percentiles. So we can compute percentiles, deciles, quintiles by the same way as percentiles. The first quintile is the same as the second decile, and also the 20th percentile. To compute the measure of position, we use the following 3 steps. Step number 1, arrange the data set in ascending order from small to large. Step 2, compute the rank or the position of the measure. Number 3, calculate or find the value of the measure. Example number 14. The following data lists the number of car thefts during 2015 in 12 cities in Egypt. Okay, so we have 12 observations. Every observation represents the number of thefts during one city and 12 cities in Egypt. Okay, find the 3 quartiles. The 3 quartiles are Q1, Q2, and Q3. Or we can say the 25th percentile, the 50th percentile, and the 75th percentiles. Okay. Number 2, find the percentile rank of the number 40. Okay, after ranking the data, we see the number 40 and count all the values less than the number 40 and divide by 12 the number of observation. Okay, divide by 12 and get the percentage of this one. Compute the interquartile range. The interquartile range, as we said before, IQR equal Q3 minus Q1. Q3, the third quartile, minus the first quartile. Okay, so let us see the solution by hand. First, we rank or arrange the data set in ascending order as follows. As you see, we rank the data set from small to large. Finding the rank of measures. RQ1, the rank of the first quartile. Now N is 12, the number of data set, multiplied by 1, which is the first quartile, divided by 4, which is the number of parts which quartiles divided the data set. Okay, so N is the number of observation, multiplied by 1 is the first, the rank of the measure, and divided by K, which is the number of parts divided by this measure, plus 1/2. So the rank is 3.1. The observation number 3.1. I mean that the observation between 3 and 4, in the middle of third value and the fourth value in the data set. Third value, this one, and fourth value, this one. So you have to add the value number 3 to the value number 4 and divide by 2. So the first quartile is the value in the middle of the third value and the fourth value. The second quartile equal 12, the number of data set or the number of observation, multiplied by 2, the second quartile, divided by 4. 4 is the number of parts, okay, plus 1/2. So the rank of the second quartile is 6.5. So the value in the middle of the 6th and 7th value in the ranked data set. So 1, 2, 3, 4, 5, 6, 7. Here the second quartile is between 21 and 26. So it's equal the average of these two values. Okay, I mean 21 plus 26 equal 47 divided by 2, so equal 23.5. Okay, the third quartile rank is 12 by 3 divided by 4 and plus 1/2 equal 9.5. Okay, so it lies between the 9th and the 10th value. So it is the average of the 9th and the 10th value. Okay, this is the 9th and the 10th value, 9th and the 10th. 34 plus 40 equals 74 divided by 2. Okay, computing the value of measures. Okay, the first quartile, as we said, is the average of 14 plus 18. This one, the third and the fourth value. Okay, equals 16. The second quartile or the median equal 21 plus 26 divided by 2 equal 22.5. The third quartile is quartile number 9.5. So it's the middle of the 10th and the 9th. 10th and the 9th. So 34 plus 40 divided by 2 equal 37. IQR, the interquartile range, equal Q3 minus Q1 equal 37 minus 16 equal 21. The percentile range of 40. Okay, now count the number of observations less than 40 and divide by the total number of observation and multiply by 100. We have 9 values less than 40, and the total data set is 12. Then 9 divided by 12 and multiplied by 100 equal 75. Okay, so the percentile rank of the value 40 is 75, percentile number 75. By MATLAB, using the function percentile or quantile. Okay, listen again, percentile or quantile, and IQR. IQR is the interquartile range, which equal Q3 minus Q1. We have, this is the data, 12 data, n equal length of x equal 12. This is the number of data set. Q equal percentile, x, the data, and between brackets, square brackets, 25, this is the first quartile, 50, the second quartile or the median, 75, the third quartile. Okay, so when using percentile, use any value between 1 and 100. 1 and 100, okay? So the value of the first quartile is 16, as we computed manually. The second quartile 23.5, and the third quartile is 37. Or another way, write or use quantile. Quantile is a function, looks like percentile, but the difference here is using the percent instead of integers, the percent. Okay, so the first quartile represent the 25%, and second 50%, and third 75%. Okay, so the decimal point here is the difference between percentile and quantile, but the answer is the same. IQR, use the function IQR of x, which equal 21. Example number 15. The following data lists the marks of 4 students, I mean the scores in statistics course. These are the marks of 4 students. Find the third decile. The third decile, as we said, is the same as the 30th percentile. The first quintile looks like the 20th percentile, and the third quartile equal the 75th percentile, and finally the 70th percentile. So we can transfer all of them to percentiles. So solution by hand. arranging the data in ascending order like this. Finding the ranks of required measures, okay, for the third decile, n equal 40, I equal 3, the third decile, so I equals 3, k equal 10 parts, so the deciles divides the data set into 10 parts, okay? So RD3, the rank of the third decile, equal 40, the number of data set multiplied by 3, the rank of the data, divided by 10, the number of parts which decile divides the data, and then add 1/2. So the rank of the third decile is 20.5. For first quintile, n equal 40 also, I equal 1 first, and k equal 5. We have 5 parts. Every part contains 20%. So RQ1 equal 40 multiplied by 1/5 plus 0.5 equal 8.5. For Q3, n equal 40, I equal 3, and k equal 4. RQ3 equal 40 multiplied by 3 divided by 4 and plus 1/2 equal 30.5. For P70, n equal 40 and I equal 70 and k equal 100. So RK70 equal 28.5. Computing the value of the measures. The third deciles equal 11 plus 11 divided by 2 equal 11. And Q1 equal 9 plus 9 divided by 2 equal 9. Third quartile, 16 plus 16 divided by 2 equals 16. 70th percentile equals 16 plus 16 divided by 2 equal 16. By MATLAB, enter the data like this. N equal length of X, the number of data set is 40. Then per equal percentile X, 30, 20, 75 and 70. Okay, so we compute more than one measure in one function, one function. Okay, so the 30th percentile is 11, the 20th is 9, the 75th is 16, and the 70th is 16. Or we can use also the quantile and use the decimal point instead of integers. So 0.3, 0.2, 0.75, 0.7, but the answer is the same as. Okay, we will stop here, and Godwin, the next lecture will be contain the measures of dispersion. Thank you, and see you later.